Chapter 8, Section 3, Solving Applications with Using Systems of Two Equations with Two Variables would be another way to expand on that. But that's the last two sections we've been focused in on. How do we create solutions for those types of systems? Well, now that we have the app or strategy, we're really using algebra, and we're taking concepts of algebra. We put those together into a problem-solving strategy called solving systems. Now that we have this, we can do more complex word problems. In fact, though some of these are probably not something that gets so more practical, or maybe not as in your life. But one of the frustrations as an algebra teacher is you get asked, when am I going to ever use this stuff? And well, the answer is always, well, you don't have enough skills really to take on something close to a real world thing and use algebra to solve it. Or another way to say is to take a real world thing that you can't solve a different way. The simpler problems like rate problems and those kinds of things, when you're trying to figure out, how many gallons of gas you're going to need to travel somewhere. You could do that with a linear equation and do that, but there's other ways to do that which would probably be a lot more practical. So we're building the skills and strategies together to see ways that we can deal with systems that are usually more in the real world, where we have things that have all kinds of variables. I mean, variables are, when we get to try to predict weather and things like that, it's a big deal when they create a computer that is capable of handling all the variables and all the information that they're gathering now with weather. And you got buoys out in the ocean gathering data, really, temperatures and surface temperatures of the ocean, wind, speed, direction, all those kinds of things. Getting some atmospheric measurements, all those kinds of things. So you get a lot of data, and they vary. I mean, from minute to minute, they're getting a varying number for all those measurements, and you need systems to solve those issues with all those variables that can occur. Time of day would be a big deal on temperature gathering too. So they're going to give us some applications, kind of like at the beginning of the chapter. This is the first chapter you have run into where they give you word problems in the very first section, and that's really what they're trying to do, is say, let me show you some reasons that we need this skill set, because it does take some time. There's a lot of steps that can occur. There's a lot of strategy. You need some discipline. You got to keep clear where you're going and why you're doing some certain things, or you'll get lost in the steps. So hopefully you're past that going through this, especially section 2. So let's look at this example. Endangered species. It says in 2012 there were 92 species of birds in the United States that were considered threatened or endangered. The number considered threatened was 3 less than 1/4 the number considered endangered. How many U.S. bird species are considered endangered or threatened in 2012? Now I could go back to section 1 right here. I think this is exactly the first word problem they gave us in section 1. But now they're asking some questions. At first they just said, hey, could I create some equations? And they wanted to say, hey, you have basically a situation where what they're giving me for information is really two equations. And that's what they're saying here. Actually, I should read before I start talking, right? Is you familiarize and translate the steps. This was completed in example 1 in section 8.1, right? And that's all they went to at that point. They say, hey, we could translate this into algebraic equations. And they came up with the sum, basically, of they defined the variables. T was for threatened and D was for endangered. And a lot of times the easy equations, the one to miss is you end up, hey, both these things, I don't know how many of each, but they both have to add up to 92. So I get this equation. And then 3 less than 1/4 D, right, endangered, that's this expression here, and they say that's equal to the number of threatened. And, they show the definition of that. So they translate this, we end up with two equations. So now we can get, because I have two equations with the two same variables, from what I've learned about solving systems, I can find an exact value or the ordered pair where both of these things are true at the same time. That's the solution to the system. Now what they do is use substitution, because we have one of our equations is solve for t. That's a pretty good indicator that substitution is a good method to try to use. So they take the first equation, t plus d equals 92, and they replace this t with the other equation, what t is equal to. So this expression here, 1/4 d minus 3 plus d equals 92. Now, I'm not going to talk about this a lot as we go on, but why do we do this? We want to create an equation with one variable so I can get a value for that variable, and then I can substitute back into one of the equations an actual number and find out what that other variable is equal to. So in this case, I'm going to apply the substitution strategy twice. And like I've went through before, substitution is something we've been doing every time we check an equation to see if it's true, if we really do have a solution. That's a substitution process, to go back and see if the number I think I should be using actually works, right? So they solve that for d, and they get d equals 76. Well, next we would go to either one of the originals. This one's a good one because I want to find out what t is equal to. Well, all I have to do is put a number in here for d and do the math, and I'm going to have a value for t, which will be 16. Then it says check. So the sum of 76 and 16 is 92. They didn't really go back to the equation, did they? They went back to more of the language of the original word problem. In other words, does this make sense in the original word problem where it says we have 92 species which are considered threatened or endangered? And what I came out with is I think I have 16 threatened and 76 endangered. Well, would that make sense? Would those add up to 92, right? That's our original first equation. And in this case it does. Okay, so it checks for that part of it. Then I need to check for the other part. Does it fit this condition here where the amount of threatened is equal to 1/4 the amount of endangered, and subtract 3? Well, it checks for there too. So this ordered pair, which has defined variables, right? What it means, again, is I wouldn't answer that with an ordered pair of well, if I use an ordered pair, the D would come first because that's in alphabetical order. It would be 76, 16. That's not what I'm going to answer with here. I need to know what that ordered pair or the solution to that system is really telling me, is that I have 16 threatened and 76 endangered, because that's what they're asking. They're saying, what's going on in 2012? Well, I have 76 bird species considered endangered and 16 considered threatened.